So welcome to my webcast today about extended events. It seems that we're just a small group, just 3 people, including me. So over the next hour, I just want to give you a general introduction about extended events in SQL Server, why we have extended events, and then I just want to give you a few specific examples how you can troubleshoot some specific SQL Server related problems with extended events in SQL Server. First of all, I just want to give you a quick introduction about my person. My name is Claudia Shabana, and I come from Vienna in Austria, and I provide with my company SQLpassion, SQL Server consultancy and training services across Europe. I'm also a Microsoft Certified Master for SQL Server 2008, which is the highest technical certification that you can achieve on SQL Server. I have also written the book Pro SQL Server 2008 Service Broker. Service Broker is an asynchronous messaging framework that Microsoft first introduced back with SQL Server 2005, and with Service Broker you are able to write asynchronous message-based distributed database applications. You can also follow me on Twitter, and you can also find more information about my person and my services that I offer on my website SQLpassion.at that you already know, of course, because you have already signed up for my webcast today. So let's talk now about the agenda. In the first few minutes, I just want to give you a quick introduction about the architecture and the design of extended events in SQL Server, and afterwards I just want to show you a few specific examples, demonstrations, how you can work with extended events in SQL Server and how you can troubleshoot some specific problems which wouldn't be possible without extended events. First of all, extended events were introduced back with SQL Server 2008, so already a very long time ago, means we have now extended events already available for almost 9 years. And more or less, extended events are just used to troubleshoot some specific performance problems or other problems on SQL Server. And more or less, extended events are just a replacement technology for SQL Server Profiler and SQL Trace. So this is also very, very important. Normally, these days, you shouldn't use SQL Server Profiler anymore because SQL Server Profiler is a deprecated feature, and SQL Server Profiler will just go away sometime in the future. Because since SQL Server 2008, we have now as a replacement technology extended events, and with extended events you can do the same thing as with SQL Server Profiler, just a little bit different. And as you will see over that hour today, with extended events you can also do much more which wouldn't be possible with Profiler, which is also very, very important. You can just troubleshoot more specific performance problems in SQL Server with extended events, which wouldn't be possible with SQL Server Profiler or even SQL Trace. And extended events are itself just based on so-called event session. The event session is more or less the same as a SQL Server Profiler trace, means within that event session you just configure which events you want to collect, and then you can configure so-called actions. Actions are just properties of those events that you want to capture, so just the information that you want to retrieve from SQL Server. You can also define so-called predicates, means you're just doing a filtering. For example, you want to capture an event for a specific database, for a specific session, for example, and afterwards you just configure a so-called target, and the target just defines into which final destination you are writing the information that you are collecting. You can write into a file target, same thing as a trace file with profiler, or SQL Server also provides you multiple in-memory targets, means you're writing directly into memory as fast as possible in SQL Server. But on the other hand, when you're stopping your event session or when you're restarting SQL Server, you will also lose that information because you're just writing into memory, so not into a durable storage. SQL Server provides you hundreds of different extended events. I think on SQL Server 2016, the latest release, we have at least, let's say, 900 or even 1000 different extended events that you can use. And an extended event is just a well-known point in the code base of SQL Server. For example, imagine you acquire a lock, you release a lock. For those actions, SQL Server provides you an extended event. The same thing when you're reading a page from the buffer pool, when you read a page from your storage subsystem, SQL Server offers you an extended event on which you can react and which you can capture. In addition, when you perform page splits in an index, in a clustered index, non-clustered index, SQL Server offers you also an extended event with which you can further analyze those page splits. And each extended event has an associated payload, means just additional information that you are requesting about that extended event. For example, when you have a page split, SQL Server tells you with that specific extended event the page that was splitted, means the page ID, and also the new page ID which gets allocated and inserted into that clustered or non-clustered index. Same thing happens when you're reading a page from the buffer pool. You have some payload information which are telling you which page ID you have read from the buffer pool and to which file ID that specific page belongs to. Those payload information are returned in SQL Server as XML data, means SQL Server just returns you an XML document, and within that XML document you have with a generic data structure those information for the extended events that you are capturing. You have also multiple dynamic management views, means SQL Server offers you here a handful of different dynamic management views which are starting with system_XE, and those dynamic management views are just specific to extended events itself. The great thing about extended events is the fact that the documentation about the individual extended events is not part of books online. That sounds terrible, but that is on purpose because you have the documentation of your extended events within the dynamic management views. So directly in front of you means when you want more information about one specific extended event, you can just ask SQL Server. You go to a specific dynamic management view, and within the dynamic management view, you have the documentation about the extended event. This is also very, very important. When you look into books online, you have only a documentation about how extended events itself are working, about the architecture and design and so on, but the individual extended events, those events are only documented and described in the dynamic management views that SQL Server offers you. A few words about the targets. SQL Server offers you multiple targets. These days means SQL Server 2014, 2016, almost all event targets are asynchronously, means an extended event is raised, is captured by an extended event session, and the information itself is written asynchronously into the target. Back with SQL Server 2008, when extended events were introduced the first time, a lot of those targets were just synchronous, means the query which has triggered that extended event had just to wait until that information was delivered into that synchronous target. And over the years, Microsoft has changed that approach, and now with SQL Server 2014, SQL Server 2016, almost all events are just asynchronously, means they are not generating a huge overhead. We have here different kinds of targets. The easiest one is the event file target. It's just the same as a trace file with SQL Server Profiler, means you're just tracing into an event file, which is physically stored somewhere on your disk, means when you're restarting SQL Server, you are also not losing here any information. On the other hand, you have the so-called ring buffer target, and the ring buffer target is just a ring buffer target is just a in-memory target, means you're writing into the process space of SQL Server.exe, means when you are stopping your event session or even when you're restarting SQL Server, you will lose that information in the ring buffer target. We have also more complex targets like the event bucketizer target, which is more or less just an histogram, means you can do group by aggregations for your captured events. Imagine you have page splits on your system and you just want to know in which database you have how many page splits. In that case, you can use the event bucketizer target and you are just doing a group by aggregation on the database ID level, and afterwards SQL Server just tells you how many page splits you have in each specific database, which is also a very interesting and fascinating target that extended events are offering us here. Event counter, quite simple. The event counter target just counts how often an extended event has occurred. So imagine you want to know if you have specific problems. Again, for example, regarding page splits, in that case, you can use the event counter target and you're just counting how many page splits you have on your system. And the most complex target is the so-called event bearing target. And the event bearing target is able to bear multiple events together. Imagine when you think about SQL Server, you have so many different events which have a begin and an end event. Imagine a transaction is started, a transaction is committed. A SQL statement is started, a SQL statement is completed. A lock in SQL Server is acquired, a lock is released. So you have a begin event and an end event. And with the event bearing target, you can bear such things, such events together, a begin event and an end event, and the event bearing target only returns you those events where you have a begin event but no matching end event. For example, with that event bearing target, you can find out if you have sessions, if you have transactions which were running into a timeout. Because in that case, SQL Server fires a SQL statement starting event, for example, but on the other hand, the SQL statement completed event is not fired when you are running into a timeout situation. So in that case, you can use that event bearing target to return those events which were running into a timeout situation. It's a very, very interesting target that we have here. And finally, you create a so-called event session, and with the event session itself, you just tie all those individual information together under an umbrella. Means you define in an event session which events you want to capture, which predicates you want to evaluate. For example, you are only interested in an event for a specific database for a specific session. Then you tell SQL Server through the so-called actions which information you want to capture. And finally, with the targets, you are just telling SQL Server into which final destination you are writing that captured information that you are getting here with that configured event session. SQL Server offers here multiple TTL statements with which we can control our event sessions. We have a create event session statement with which we can create an event session with alter event session. You can change your event session. For example, you can drop a specific event from it, or you just reconfigure your event session. And finally, with drop event session, you again just remove that event session from your SQL Server system. Perfect. Let's switch now over to SQL Server Management Studio, and now I just want to show you a few specific examples how you can work with extended events. In the first step, I just want to show you why using Profiler these days is not really a good solution anymore. First of all, as I've already said, SQL Server Profiler is a deprecated feature, means maybe sometime in the future you're installing Profiler, you're going to the tools window, and Profiler is just gone away. Means it's already a deprecated feature since a few SQL Server versions, even very easy to prove that. You start here, for example, in an event session, and you capture the event deprecation announcement. That event with SQL Trace is always raised when you're using a feature, a functionality in SQL Server which is marked as deprecated. Means when we create that event trace, and afterwards we are starting SQL Server Profiler again, and we create here a simple trace. You can see now in the first Profiler session that SQL Server Profiler itself has just said that SQL Server Profiler is just deprecated. Profiler itself is just a front-end application across SQL Trace. SQL Trace is just a tracing infrastructure that SQL Server offers us already for a very, very long time, and SQL Trace just consists of some internal system stored procedures. For example, sp trace set event means Profiler itself just calls those system stored procedures, and those system stored procedures are just marked as deprecated within SQL Server, and therefore we are getting here those events deprecation announcement. And you can even see how such a SQL Server Profiler session is configured with SQL Trace. For example, I'm running here default trace of Profiler, and when you go here to export, you can script that trace definition into a SQL file. Let's do that. Means we have now a SQL file. And when we go now to SQL Server Management Studio, you can open that file. And as you can see now, here you have those calls to those system stored procedures which are now already marked as deprecated. For example, with sp trace create, you create a trace, and your trace ID is the output. You specify your file name and so on. And As you can see with sp-trace set event, you are configuring now for that specific trace ID which event you want to include in that session and which columns of that event you want to include. So as you can see in that event number 14, we are including here 7 columns with the ID 1, 9, 10, 11, 6, 12, and 14. And as you can already see, this is very, very hard to understand. Almost no one of us has currently an idea what is event number 14 and what is the column ID 1, 9, 10, 11, 6, 12, and 14 of event number 14. You have to look up that in books online. Means SQL trace is in no way self-describing. This is just very, very hard to understand when you have such a SQL file in front of you and you want to know which events you have to capture. You have to go to books online and just look up what those individual IDs just mean. And finally, with sp-trace set status, you can start that trace by passing in the internal ID 1. Means 1 means just starting a trace, 0 or 2 just means stopping the trace, and finally 0 or 2 just means deleting that trace, again from your system. So very, very hard to understand. So from that perspective, it doesn't really make sense anymore to use Profiler. It's a really, let's call it stupid technology that Microsoft provides us here. But the great thing is, since SQL Server 2008, we have now extended events. They are integrated within Object Explorer. That's new since SQL Server 2012. Means in SQL Server 2008 and SQL Server 2008 R2, you had to do everything manually through the SQL statements. And here now, with extended events in SQL Server 2012, 2014, 2016, you have even the integration within SQL Server Management Studio. And I just want to show you now a few specific examples how you can work with that. First of all, I want to show you how you can analyze so-called sort warnings with extended events. Let's try to engineer a very simple example. I'm creating here a new database, and within that database, I create a new table. I have on the first column a primary key constraint, means SQL Server creates in the background a unique clustered index for us, and on the second column we just create a non-clustered index. And I'm inserting into that table 1500 rows. Means we have here a very simple table in front of us. As you can see from the output of statistics.io, when we read from that table, we have here 377 logical reads. Not that bad. And now I'm just running here a simple select statement where I'm doing an order by across the third column. We have currently no index on that column, means that data is in no way sorted, means when we are running that statement, you can see now in the execution plan, we have an explicit sort operator, and as you can see in the tooltip window at the very bottom, we are ordering by column 3 so that we return from that query a sorted output. The most important thing here is SQL Server uses for that sort operator internally the so-called merge sort algorithm to perform the sorting. And the merge sort just needs some memory to make the sort itself happen. And as you can see at the select operator, in the fifth row, we have here so-called memory grant of 1 megabyte, 1024 kilobytes. So SQL Server has acquired for that query execution a memory grant of 1 megabyte, and that 1 megabyte is used by that sort operator internally. And the size of that memory quant is calculated based on the estimated numbers of rows, which are coming from the statistics. As you can see, we have here currently no problems with our statistics. Our estimation was just one row, and in reality we also returned one row. Means in that case that sort operator was just running in memory as fast as possible. And what we are doing now, I'm fooling SQL Server. I'm inserting now into that table 799 additional rows. Why 799? Quite easy. I want to prevent that SQL Server auto-updates our statistics. Our statistics are updated if 20% plus 500 rows are changed on a table since the last update of our statistics. We have a table of 1,500 rows currently, means 20% of 1,500 is 300 plus 500 is 800. Means we need now 800 data changes so that SQL Server will auto-update our statistics. And we just insert here 799 new records. But SQL Server has no idea from those records because our statistics are not updated. And guess what? I'm inserting now into the second column 799 times the value 2, which is currently only once in our table, as you can see. And now we are getting 799 additional value 2 values. But SQL Server has no idea about that one, means our stats are not updated, and SQL Server just reuses the cached execution plan. And this, of course, as you will see, will cause some performance problems. When we run now that query again, SQL Server just reuses the same plan from previously that we have cached in the plan cache. And you can see now estimated numbers of rows is 1 and actual numbers of rows is 800. Means we have now an estimation of 1 row. Therefore, the query optimizer has optimized previously that execution plan under the assumption that we just return one specific row from that query. But currently we are returning 800 rows. Means we have to perform that lookup operation 800 times. You can see number of executions. As you can already see, we have here 1605 logic reads because we are doing that lookup over and over and over again, and each lookup costs us 2 logic reads. First problem, that bookmark lookup is inefficient, and the second problem is now our sort. Our sort operator thinks that we have just one row to sort, but in reality we have 800 rows to sort. And therefore, as you can see with that exclamation mark, that sort operator spills over to DempDB. You can see we have a sort warning, and SQL Server tells you that we have written 200 pages to DempDB, and we have read again those 200 pages from DempDB. That's just physical overhead. Normally, a sort operator just happens in memory as fast as possible. But currently, that sort operator happens in DempDB because that memory quant is just the same, 1 megabyte, under the assumption that we are just sorting one row. And as you can see in the messages window, that query takes now 43 milliseconds, and we have here a work table associated. When you see in the output of statistics.io work tables or work files, it just means that you are accessing your DempDB. And you can see we have here 200 so-called read-ahead reads. Physical I/O in our DempDB, which causes that query to be slower. And now you want to troubleshoot that specific problem. Imagine you have now a system and you just want to find out if you have sort warnings. Let's try to do that in the first step with Profiler. As you will see, Profiler doesn't help you here that much. Let's create a blank trace. And as you can see, we have here errors and warnings. And we have a sort warning. So SQL Server Profiler SQL Trace offers you a sort warning event. Let's run that. And let's run that query again. As you can see, we have captured that sort warning event. But this is almost useless because SQL Server doesn't tell you that much. SQL Server tells you the application name, database ID 7, database name. You have your login, your username, your session ID. That's it. SQL Server doesn't tell you here in any way the query or even the plan handle of the execution plan. SQL Server just tells you you have a sort warning event. One query spilled over to DempDB, but SQL Server doesn't tell you in any way which query. This is stupid, to be honest. Means there's not really a reliable way with Profiler to find out now which query has spilled over to DempDB. Profiler just tells you, yes, you have problems, but I'm not telling you in which query you have those problems. Therefore, that sort warning event is almost useless. Let's try now the same thing with extended events. As you can see, you have here a session wizard. You give that event session a name. Let's call it track sort warnings. You can even configure that event session in a way so that SQL Server just automatically starts that event session at SQL Server Startup, which could be also handy when you troubleshoot some specific programs. You can use a specific event session template, the same as you have in Profiler. You can even include here your own event templates if you want. We don't use here a template. And now you have here an event library. Means you have here all the individual events that SQL Server offers you. As you can see, those are hundreds, maybe thousands of different extended events that SQL Server offers you here on my SQL Server 2016 instance. Let's try now to check if we have a sort warning event. Yes, we have one, as you can see. You can search all those events directly. Those events are held in a dynamic management view, means you can just sort them or you can just search them with traditional SQL statements. And think about that one. You have a documentation in front of you, which is again part of those dynamic management views. Let's have a look on that dynamic management view. system.exe object means in that dynamic management view I have here almost 2000 rows, and here you have the different objects. For example, you have your events, you have your actions, you have your targets. Means when we restrict here on object type equals event, you can see now on SQL Server 2016 we have 1303 extended events available. You have the name of the extended event and you have a description, which is awesome because you can work now with them. Imagine, let's search for an extended event about sort warnings. We have here a few. Sort warning, the same page split, for example. We have a page split event when you're interested in some IO related extended events. We have 317 here available. Just think about it. It's very, very easy to analyze all that information because you have everything stored in those dynamic management views. As I've said in the beginning, when you look into books online, all those extended events are not described because you have that description directly available in that dynamic management view. And that's really, really awesome. And that wizard just uses those dynamic management views in the background to give you that sort warning event. And again, you have that documentation. Of course, that documentation here about the sort warning is great. Very, very nice. On the other hand, for example, when we look on page split, that documentation is stupid. Maybe this was a different developer at SQL Server. So it also depends on the developer which has introduced that extended event, how good that documentation is. So we have that sort warning event in front of us, and we add now that sort warning event to our event session. And now we continue. And here you have now those actions that I have mentioned previously. Means regardless of the extended event that you have chosen, you have always some specific information available. For example, it doesn't matter which extended event you capture. You always have, for example, a database ID. You always have a session ID. You always have a SQL statement, and you always have a plan handle which identifies your execution plan. So it doesn't really matter which of those 1,300 extended events you are capturing. SQL Server always gives you back those information that we have in front of us. You always have a plan handle. You have always a session ID. You have always a SQL statement. So even here with sort warnings, we are able to find out in which statement we have that sort warning and how the execution plan looks like. And this is amazing compared to Profiler. Normally it's just a functionality that you expect from a database. And then you can define filters. For example, let's filter on a specific database ID. Let's check which database ID we have. I think it was 7. Yeah, it's 7. And now we are filtering on that database ID. Means in that case, we are making that extended event session as restrictive as possible. In that case, we are now only capturing sort warning events which are happening and raised in database ID 7. This is also very, very important. When you work with extended events, you should make sure that your event session is as restrictive as possible. You just want to generate as less overhead as possible with your extended event session. And then finally, you specify your data storage, just your target into which you are writing that information. For example, we can write now everything into a file target. So let's write that to cdemp track sort warnings, and those event files have an extension of XEL. You can specify the maximum size, and you can also specify how many rollover files you want to use. Again, almost the same thing as with Profiler. Or you can also write everything into a so-called ring buffer target. Means you can write here into multiple targets. I'm writing once the information physically into my storage subsystem, and in addition we are writing also everything into a ring buffer target, which is just an in-memory target that extended events are offering you here. And finally, let's script everything out so that we can see now how that TTL statement looks like. Let's format that a little bit in the first step to get a better understanding. And as you can see, we create an event session. The event session has a name. It's always on server. And then with add event, you are just adding the individual events in which you are interested in. For example, in that case, we are interested in this event sort warning, which is stored in a package called SQL Server. Means SQL Server just offers you or just groups those individually extended events in different packages. For example, one very prominent package is, for example, SQL Server. And then we have that action block, and within that action block, you just define which global information you want to capture. In our case, we want to capture the database ID, we want to capture the plan handle, session ID, and SQL statement. And all those actions are also part of that package SQL Server. And then we define here our filter. Means, as you can see, we are filtering here on the database ID 7, on the database sort warning. When you have an additional event that you want to capture, you just do comma and add event blah blah blah, and you do the same thing again. So a very simple syntax that we have here in front of us. And finally, with add target, we are just adding our individual targets. Event file target is defined in a package 0. Package 0 is more or less just a package which provides you common functionalities like the event files. And then for the event file target, we're just setting our file name. Means the file name into which we want to write. In our case, track sort warnings.xel. And finally, comma, and we add our ring buffer target, which has no specific properties here. And finally, with the with statement, you can specify if that extended event session should be started automatically when SQL Server is starting. So let's create that. Means when we go now to Object Explorer, you can see now we have here that track sort warning event session, which is currently stopped. This is also very, very important. By default, when you create that event session is always in the stopped state. Means you also always have to explicitly start that event session. Means you can see here now we have the two targets, the event file and the ring buffer target, and now we start that session. You can also do the starting with the SQL, so you just do an alter event session sort warnings on server state equals start. Means that event session is now running. And what we are doing now, let's run that statement which triggers our sort warning just a few times. Means we are now capturing those sort warnings in that extended event session. Means when we look here into the ring buffer target, you can see now we have here XML information in front of us. As I've said previously, SQL Server returns you the whole information about the captured information as XML data. Means when you want to analyze that information in a more sophisticated way, you also have to work with XQuery. Means SQL Server provides you here functionality so that you can query those event sessions programmatically, and then you apply XQuery queries so that you can analyze that XML data. But trust me, XQuery is a very, very complicated programming language. And as you can see, we have here now, I think it was 11 sort warning events that we have captured for the database ID 7. And within that event, SQL Server tells you the payload information. So each extended event just has different payload information like the sort warning type. You see here your degree of parallelism, means that query was running single-threaded, how large your memory grant was, in our case 1 megabyte. You can see how much you have written and read from that work table in DempDB, the 200 pages that Statistics.io has also told us. You can see how much rows we have spilled over to DempDB, in our case 800, and we have our SQL statement. Means the SQL statement that SQL Server Profiler hasn't provided us in any way. We have it here just as an action information. Means, as I've said, doesn't matter which extended events you capture, you have always the SQL statement. And regarding the question from Alexandru, we have here 11 extended events because I have also executed that query 11 times. I've just hit multiple times F5. So I've just executed that query multiple times. Therefore, we have here 11 events captured. We have our session ID 54, and finally, also very, very important, we have our plan handle. Means with that plan handle, we can go now to the plan cache and we can request the estimated execution plan. Means we grab that handle, and what we are trying to do now, we call systemexec query plan and we pass in that plan handle. But this doesn't work. Incorrect syntax. The problem here is the following. The plan handle is a hex value, means within that information the 0x is missing. To identify it as a hex value means when you grab a plan handle with extended events, you have to add the 0x at the beginning so that you get a valid plan handle. Terrible. But yeah, that's the way how SQL Server works. Means we are getting here now back our execution plan and we can visualize that execution plan. Of course, we have only access here to the estimated execution plan. Means within the estimated execution plan, we have no idea what happens during runtime. Means in that case, we have no actual numbers of rows. They are not part of the estimated execution plan that the query optimizer has compiled us. And of course, we have also no idea that that sort operator spilled over to DempDB, because all those things are just happening in the actual execution plan, but the actual execution plan is never ever stored in the plan cache, because of course the actual execution plan can be different for every individual query that you're executing. So this is also very, very important. SQL Server can only return you the estimated execution plan. But based on the estimated execution plan and based on that information that we have here in front of us, we know that that sort operator spilled over to DempDB because of inaccurate statistics. Means what we can do now, we go to that database. You see we have both indexes, our non-clustered and clustered index with their associated statistics objects, and I'm just rebuilding now, for example, my non-clustered index that SQL Server is referencing here in the execution plan. Means when you rebuild an index, clustered or non-clustered, SQL Server also auto-updates the statistics as a side effect. So as you can see now, that statistics object was auto-updated, and now when we run that query again, let's close that one in the first step. Now let's close that one, and finally we have here our query, and when we now run that query again, and when we look at the execution plan, you can see based on that statistics update, which was finally triggered by the index rebuild operation, our plan has changed. We are not doing the bookmark lookup anymore, because doing that lookup 800 times doesn't really make sense. Means we're just performing a clustered index scan, and very, very important, we have now accurate statistics. Means we have estimated 800 rows, we got those 800 rows, and based on that estimation of 800 rows, SQL Server has acquired a memory grant of 3.7 megabytes. Means our memory grant is just larger, and therefore our sort operator is now running in memory. Means that sort operator is not spilling over to tempdb anymore. As you can see on that work table that we have here, there are no read ahead reads and there are also no logical reads anymore. This is also very, very important that sort operator happens now directly in memory. Very easy to prove. Let's look again into that ring buffer target. You can see we have here total events processed 11. And when we run now again that statement a few times, and when we open that ring buffer target again, still just 11 events processed. Means now we haven't triggered any sort warning anymore. Quite easy. And finally, when you don't need that event session anymore, you just stop it. Of course, the problem is when you have stopped that event session, you have lost the data in your in-memory targets. As I've said, we are just writing here into the process space of SQL Server.exe. But we have written everything into the event file target. So what we can do, we go to cdemp. We restrict here on XEL, and we have that event file. And within that event file, you have again your 11 sort warning events that we have captured. And again, you have the same information. You have the plan handle, you have your SQL statement, you have your memory grant, you have your session ID. So this is also very, very important. For example, when you have specific performance problems that you want to troubleshoot, I can send you an extended event session definition. You write everything into an event file target, and afterwards you're just sending me that event file target, and I could afterwards analyze that requested information for you. Means when you are writing into an event file target, you're not losing here any information. As soon as you're stopping the event session or when you finally drop that event session, you of course lose the information of your in-memory targets. Perfect. So we are now already at the end, and I hope now that you have a better understanding about extended events. Main outcome for today is just make sure that you're not using Profiler that much anymore. Of course, I know Profiler is just easy because we have used Profiler for so many years, but Profiler, as you have seen, has a lot of different disadvantages, and Profiler also generates you a huge overhead for your system. So the next time when you go to Profiler, just close Profiler and just try to do the same thing with extended events. It's possible with extended events. Since SQL Server 2012, you have the same events from Profiler, part of extended events, means you can do the same thing as with Profiler, and much more, as we have seen. As you have seen with the sort warning event, it's quite easy to find out in which SQL statement you had that sort warning, what was the estimated execution plan. So this is already more information that SQL Server offers you here with extended events. And as you have seen on SQL Server 2016, you have more than 1,300 extended events available, so much more information as Profiler provides you.